If you write any code in Python, then you'll see these 10 Python functions a ton, and it's important you master them. Some of them may seem simple, but they have a lot of additional parameters that you need to understand, as they can save you a ton of time. So with that said, let's dive in and look at function number 1. So the first function we'll look at here is the print function. Now this is probably the first thing you learn when you learn Python, and it seems super basic. We can print out a few different things, we can separate them by commas, and you can see that we can print a mix of strings and variables, and when we do that, they'll get printed out separated by a space. But what you probably didn't know is that we can pass additional arguments to the print function that modify how it works. For example, I can pass this sep argument here. So sep is equal to, and I'll go with something like a pipe. And now what will happen is rather than using a space as the delimiter, or what goes in between the different arguments we pass to the print function, we'll use this pipe. So when I run the code now, you see we get my name is, and then pipe Tim, pipe, and I am pipe 23, pipe years old. So we can override that default behavior, which is to use a space to separate all the different things we're printing. And in this case, we use a pipe. Now, maybe instead we want to use a comma. So let's go back here and change that to a comma and print this out. And now you can see that we're printing things with a comma. This is quite useful, especially when you want to print out things that have a certain formatting and you don't want to do the manual formatting yourself. Now, another thing we should know about the print function is how we change what gets printed at the end of the line. So you may not know this, but by default, when you print something with this function, it's going to actually add a \n, which is a new line character, which will force the terminal to go to the next line. So when you print something else, it won't be on the same line. Now, typically this is what you want. And that means when I run the code here, you'll see we get these two print statements on separate lines. But sometimes you actually want to print things on the same line, so how do you do that? Well, what we can actually do is we can override this end argument here, and we can pass this something different than the new line character. So I could pass, say, end is equal to a pipe, and maybe put some spaces around it. And if we clear here and run, you'll see now we get hello world, and at the end of this print statement, it prints the pipe with the spaces, and then when we go to print the next line, it will happen on the same line here because we didn't move down to the next line. So now we're going to dive into the second function here, which is the help function, but first I need to share with you something that's going to be very helpful, and that is the sponsor of this video. Today's video is sponsored by Mailtrap, an email delivery platform that developers love. Now, what's cool about Mailtrap? It's actionable analytics, the best in the industry, with full statistics and drill down reports on each and every email you send. Mailtrap offers separate streams for transactional and bulk emails, SMTP, and API integrations, plus SDKs for major programming languages. At Mailtrap, human support is available round the clock for all customers. Try today at mailtrap.io. So hopefully you appreciated that segue there, but now let's have a look at the help function. Now the help function allows us to print out the documentation of a Python function so that we don't need to go to the internet to look it up, and we can really quickly get access to how a function works. Now what this will do is read the doc strings of a function and simply give it to us. So what I can do is something like help, and then I can pass to this maybe the print function. And notice I'm not calling the print function, I'm just writing the name of it. And now when I run the code, you'll see that it actually prints out all of the documentation for the print function. This is what's contained in the doc string for it. So you can see it says print, it kind of shows you an example of how it works, and then it gives you a description of the different arguments or the parameters for this function. Now this also works for your own functions, so let me show you that. So you can see here I've written a custom function called testfunc, and I've just written a doc string for it just as an example so we can see how this works. Now when I run my code here, notice it will actually give me the documentation of this function. So it says A, B, and then the return type. Again, it's really just printing out what the doc string is that's written here. So this is useful for built-in functions, but also when you're working with a library or code written by other people. So you don't need to search through and find the actual function definition. You can just use this help function and it will print it out for you. So the next function on my list is a very common one, and you've probably seen this, especially if you're working with a for loop, and that is range. Now, as much as range can be used to iterate through values in a for loop, we can also use it just to generate a list of numbers, and I'll quickly walk through how it works because it is a very important function. So what range will do is generate a range of numbers starting at some value, stopping at some value, and stepping by some value. Now by default, when you only pass one value here to the range function, this acts as the stop. that means it's going to go up to but not include this number, and it's going to start at 1 and step by 1, which means go up by 1 each time. So if I run the code here, you can see that this gives us the values 0 through 9, again because we go to the stopping point but we do not include it. Now if I have a second value here, something like 2 and then 10, this will act as the start value and this will act as the stop value. And now when I run this, you see that we will simply start at 2 and we will go up to 10 but not include it. If I decide to add a third value here, something like 2, this will act as the step value and this will be the increment that we will go up by each time. So if I run this here, we get 2, 4, 6, 8. Now this is quite useful and we can do this in many different kind of ways to generate a lot of different sequences of numbers. For example, I can change this to a -2 and I can swap these values around and go maybe 10, and maybe we're actually going to go to something like -10. And now this will give us a negative range where we start at 10 and we subtract 2 each time until we hit the stopping value of -10, which we do not include. Very useful for for loops, but also if you convert this range into a list, then you can simply use it as a list of values. One thing to note, if you print out range itself, which we can do here, you'll see that we actually get a range object. That's because range returns to us something known as an iterator. An iterator is something that we step through using kind of a specific process that I don't need to get into in this video. The point is, if you want to actually get an entire list of values, you do need to manually convert this to a list. Okay, so to do that, we just write the list function around range, and then as you saw before, it gives us a list of values rather than this range object, which again is an iterator. Now the next function we're looking at is the map function. Now a map function allows us to apply a function to every single item in an iterable object. An iterable object is anything that you can loop through, so something like a string, a list, a tuple, something like a set, it works for all of those. So let's have a look at a quick example. So let's say that what we want to do is we want to get the length of all of the different strings in this list. Well, we could iterate through every single one of these strings, manually apply the length function, and then just print it out or store it in a new list. But instead, we can actually use the map function that does all of this for us. So I can say the lengths is equal to, and then I can use my map function. And the first thing I pass to the map function is the function that I want to apply to all of the different items in my iterable. So in this case, I pass the len function. We can pass our own function, or in this case, a built-in one in Python. And then I pass the iterable that I want to apply this to, which is strings. Now what I can do is I can print out, and I need to convert this to a list because again, this is going to return an iterator, so it's going to return a map object. If we want to see all of the results, then we need to first convert it to a list. And now if I run my code, you see that it gives me the length of all of these different items. So it simply took this function, applied it to every single item that was in this list, and then gave me that result inside of, in this case, a new list, or really a new iterable that we converted to a list. Now in this case, we used a built-in function in Python, but we can also use a custom function that we write ourselves. Now it's common here to use what's known as a lambda function. A lambda function is a one-line anonymous function where you can do something like lambda. You can pass a parameter, in this case it will be x, and then if we want, we could do something like x plus s. Now what this is going to do is it's going to pass every single one of the strings to this function as the parameter x, and we're simply going to add an s to all of these different strings. So now what I'm going to do is run this code, and you can see we get an s tacked on to every single one of these strings. Now if you don't want to use a lambda function, you can define your own functions. We can say add underscore s. We can take in our string, okay, and then we can say something like return and then string plus s, and now we can just put the name of this function. Notice I'm not calling it, I'm just putting it as the name, and then when I run this, you can see that we get the exact same result. So that is map. It is extremely useful. Again, you pass the function, you pass the iterable object, and then it will apply this function to every single item and give you all of the results. So now we're moving on to the next function, which is the filter function, which is closely related to the map function. The way the filter function will work is it will take every single item in our iterable object, it will pass it to some function, in this case it's called the filter function, and if that function returns true, it will keep that item, otherwise it will remove it from the result. So let me show you an example. We'll just say filter is equal to, and then we're going to use filter. Same thing, we're going to pass our function. In this case, I'm going to pass this custom function I wrote called longer than 4, which just returns true if the length of a string is greater than 4. And then I'm going to pass my iterable, which is strings, and we are going to print out the list of our filtered. Okay, so let's spell that correctly and let's run our code, and notice that we only get world and apple. The reason for that is what really happens here is we take every single one of our items. So we start with my, we pass it to this function. This function returns false because my is not a length greater than 4. We pass world, we return true because this is length 5. Same thing with apple, length 5. Pear is length 4, so it's not greater than length 4, so we don't include it. So we end up with world and apple. Obviously, this is a very simple function. We can write very complex functions, and this allows us to filter an iterable object based on some function, which can be very, very useful. Mess around with this, and also remember that you can use the lambda function as well. So we could have written it like this, lambda x, and then we could say len x is greater than 4. And to prove that to you, if we type this correctly and we run the code, you see that we get the exact same result. So the next function to look at here is a simple one, and this is the sum function. The sum function is simply going to return the sum of all of the different numbers that you pass it from some kind of iterable object. In this case, we're passing an iterable, which is a set. We could pass a list, we could pass a tuple, doesn't matter so long as the values inside of the iterable are numbers. If they are not numeric, so not an int or a float, then you are going to get some kind of error. So quickly we can run the code here, and you can see that we get the sum of 35.5. Now, one thing you might not know about the sum function is that you can actually pass to this a start value. So we can pass a start of, say, 10, and now we will start summing at 10, so now you'll see we get 45.5. Now, of course, we can make this a negative value as well, so let's go ahead and do that, and you can see that this works perfectly fine. Now, the next function on my list is the sorted function. Now, this is pretty straightforward. This is going to sort an iterable object in ascending or descending order, depending on what we tell it. Now, in this case, we just have a bunch of different numbers. By default, it's going to sort this in ascending order. So if I run the code here, you can see that we get these numbers sorted in ascending order. Now, there are a few different arguments that I can pass to this sorted function to change its behavior. For example, I can pass reverse, if we spell this correctly, equal to true. And then when I run my code here, you can see that we actually get all of the values in reverse order. But another more interesting argument we can pass here is a key. Now, the key will actually be a Python function, and we will apply this Python function to every single item inside of our iterable, and we will sort the items based on what's returned from the key function. Now, I'm going to show you a better example of this, so stay with me for 1 second. Okay, so I just created a better example here so you can see how this works. So I have a list of people. And notice that if I try to sort this list of people, we just have Python dictionaries here, and the sorted function isn't really going to know how to sort this. It will do some kind of sort for us, but it's going to be pretty unpredictable. So instead, what we do is we pass to this a key. Now, this key is a lambda function. We take in one argument, in this case, it is person, and in this case, we get access to the person's age. So what we're doing effectively here is we're sorting these people based on their age. So now, when I run the code here and we print this out, you can see that we get all of the people sorted in ascending order based on their age because we're sorting all of the different items using this key. Now, if we wanted to go a step further, we could reverse this as well. And now we could sort this in descending order. And you can see we can start with the oldest person and go to the youngest. Moving on, the next function to show you is enumerate. But in order to see the value of enumerate, we first have to look at what happens when we don't use it. So oftentimes when we're iterating with a for loop, we want to have access to both the index and the value when we're looping through something like a list. In this case, you see that I create a simple for loop. I say for index in range and then the length of tasks. And then I use that index to access the task that's at that specific position. I then print out index plus 1 and then the task, and this gives us kind of a nice list. So if we run the code here, you can see that we get a list of all of our various tasks. Now this is fine, there's nothing wrong with this code. We can clean it up quite a bit by using the enumerate function. Now this is helpful again when you want the index and the value iterating through some kind of iterable. So what I'm going to do is change this here to use enumerate, and I'm going to enumerate over tasks. Now, when I do that, the first value that I'm going to have access to here is the index, and the next value will be the task. So what enumerate will really do is it will return to me a tuple for every single object, where the first object inside of that tuple is the index, and the second object is the value. So now what I can do is I can clear this and I can run, and you see we get the exact same thing. So again, first variable is going to be the index, second value is going to be whatever the value actually is, and we can use that for enumerate. Now it's also worth noting that we don't need to use enumerate just in a for loop. If we print out, for example, the list representation of enumerate, you will see what we get, and it is a tuple where we have the index first and then the value, index, value, etc. So moving on, the next function on my list is the zip function. But in order to understand the value of using the zip function, we first have to see what it looks like when we don't use it. So in this case, you can see we have two lists, right? We have names and we have ages. Now these have corresponding values. So the name at position 0 corresponds to the age at position 0 in the other list. So what I'm doing here is I'm looping through both of these lists at the same time, and then I'm printing out name is age years old. I'm essentially combining these two values together and using them in some kind of expression. Now notice that what I had to do here with my range is I had to get the minimum length of the names and the ages list. The reason why I had to look for the minimum is because if we have an extra age or an extra name, then we'll get an index out of bounds exception when we try to access the corresponding position in the other list. For example, if we add another name like Tim here and we don't have a corresponding age, when we look for the age at that index, if we were just looping through the length of names, then we're going to get an error. So I have to look at the minimum. Okay, so when I run this code, you can see that we get all of the different kind of printed out statements here. Alice is 30, Bob is 25, etc. Now this is fine. Again, nothing wrong with this code, but let me show you how much easier it is for us to actually execute this using the zip function. So I'm going to paste this in here, and you can see that now we're using the zip function. Now what the zip function will do is combine different iterable objects together and automatically handle when one iterable object has more objects than the other. So in this case, what's going to happen is it's going to combine our names and ages into actually a list of tuples, and then this allows us to loop through them really easily. So let me just run this so you can see how it works, and then we can break it down more in depth. So first, let's print out what the zip actually looks like. So I'm going to say print combined. And you can see when I do that, we actually get a bunch of different tuples, right? So we get the name, then we get the age, name, age, and notice it didn't include Tim because we didn't have a corresponding age. Now, if we wanted to go a step further, we could actually include another list. So we could have maybe a gender, and we have female, male, and then male. And now notice if I add my gender in here, and then we add gender here, and we go and is gender, when we print this out, you'll see that we're only going to get 3 lines this time, and that's because the minimum length of all of the different lists we had was 3. So it can combine as many different iterables as we want and automatically handle when we have a mismatched number of them. So again, we get Alice 30 female, Bob 25 male, Charlie 35 male, and then we can print all of this out. Zip is super, super useful. I use it all the time, and I'd highly recommend you use it in your code as well, especially when you have corresponding values in multiple different iterable objects. So now we move on to the final function on my list, which is open. Now, open can be used to open a file, read to it, write from it. It has a lot of different usage, and let me explain to you how to properly use it. So first, let's create a variable called file, and we'll use the open function. And the first argument we pass to open is the file name we want to open. So I'm going to go with test.txt. Now, the second option is going to be the file mode. There's a lot of other options as well, as you can see here, and there is a lot of different modes. Now, the most common modes that you're going to need to know about are going to be R, which stands for read, W, which stands for write, and then A, which stands for append. Again, there's a lot of other options, but these are the 3 main ones you want to know. Now for now, we're going to go with W because we want to create a new file. And when you use W mode, this is going to override a file if it already exists and essentially clear everything that's inside of it. So make sure you're careful when you use this. So now we've opened our file. What we can do is write to it. So we can say file.write. And when we write, we can just write some string. So something like hello world. And if we want to move to the next line in the file, we need to make sure we use a backline or a new line character, sorry. I can say hello world, my name is Tim, like that. So now if I run my code, you'll see that a new file is created and we have hello world, my name is Tim. However, it's very important that after we create this file and we write to it, that we close it. So we need to actually say file.close just to make sure that we don't have any memory leaks and we don't leave the file open in memory when we actually don't mean to do that. Now in this case, everything's fine if we don't actually close it, but we just want to make sure that we do close it. Now that's actually why I'm going to recommend that when you are working with files, rather than manually opening and closing them like this, you use the syntax, which is the following. Now this is the with syntax. So you're going to say with open, and then again we can go our test file.txt, put our mode as W, and we can say as, and then in this case, file. And then we can say file.write, and whatever we want to write here. Okay, that's great. And now anything that's indented will happen inside of this context manager. That's what this is referred to. And as soon as we exit this, so as soon as we finish our operations, it's automatically going to handle closing the file for us. So this is the best practice when it comes to working with files. Rather than opening and closing them yourself, you always use a context manager, which will ensure that the file is always closed properly, even if an error occurs inside of the kind of lines where you're trying to manipulate the file. So just make sure you do that. Anyways, we have the mode, so we have W, we have R. Now if we use R mode, this allows us to actually read the contents of the file. So to do that, we can say file.read. And if we read this, we will get all of the text inside of here. So we can say print and then text. So let's print that out, and you can see, hello world, my name is Tim, gets printed. And then if we want to, we can also append to a file. Now appending to a file is not going to override it. It's simply going to add to the end. So if you want to keep adding to the end of a file rather than replacing the contents inside of it, then you use the append mode. Now what we can do is say file.write new addition like that. And if we run the code here and we open this up, you can see that we have the new addition getting added. Now it's just going to get added at the end of wherever the file was. So in this case, we didn't have a new line character, so it just gets smushed to this line. If you wanted it to be on a new line, then you would need to add the new line character like that. Now there are also combination modes. So for example, you can do something like WR mode, right? Where you're reading and you're writing to the file. You can have like RA mode, I think. That's probably a mode. I'm not sure if that's actually a valid one. Reading and appending. And there are all kinds of other modes that you can look up, and you can even ask ChatGPT to tell you. It's just too many for me to cover in this video. Anyways, with that said, that is going to cover the 10 Python functions that you need to master. I hope you found this video helpful. If you did, make sure you leave a like, subscribe to the channel, and I will see you in the next one.